Hi, it's me, Marcus, from Everything Digital Health. Got a bit of a different episode for you today. This is essentially an announcement, a bit of a debut of something I've been working on for about a week. It's related to SNOMED-CT, which is a clinical terminology that we use in the NHS, and it's used internationally. I have to say, much as SNOMED is the only game in town, as I'm told, I find it incredibly frustrating because the tooling and the educational resources around SNOMED are absolutely impenetrable. And maybe that's just me, but I think it's probably not just me. It feels very much like the existing tooling that's out there is aimed at organizations that have both terminologists and technical people there to help you. And if you don't have that, you're stuck. So just the getting started stuff, if I want to understand how SNOMED goes together, I can sort of read some dry documentation, but if I want to play with it, I need a terminology server, or I need to get access to somebody else's terminology server. A lot of those are on the web, they're quite slow, they're actually a little bit shit when you look at the user interface. So we've got bad tooling, a lot of it's not very accessible if you aren't capable of setting up your own server. There's the whole licensing issue, which I haven't, I can't solve that with this. It's still, I find, a problem. But even if you get past all that and you get access to your local SNOMED TRUD equivalent, in the UK we have this thing called the Terminology Reference Update Distribution, I think it stands for, TRUD, which I've talked about before because it's awful. And that's where you get a copy of SNOMED. But when you go there, there's all kinds of different editions. Nobody helps you. There is nothing that sort of guides you to what you need. So basically, you either already know what you want, or there's no way to find out. And I'm not a stupid person. If it was easy to work this stuff out, I would have worked it out. And I have to say, it's a real failing of the SNOMED community that they have not made it easier for people to sort of get on the bus. And it's probably negatively affected their adoption. It's almost certainly negatively affected the kind of tooling and the user interfaces that are out there. That sort of thing is the stuff that frustrates me about it. And so I decided that I would have a go at building something that I could use, and mainly for my own educational purposes and sort of getting started. That actually didn't take as long as you'd think. Claude Code, coupled with the existing knowledge that I had and software development practices that I've practiced over the past sort of decade and a half, wasn't that hard to get something useful. So I'm going to just walk you through that. I'm going to show you the sort of first 5 or 6 features of it, just to show what can be done. If you find it useful, it is all open source. You'll be able to play with it and use it yourself. I'd really appreciate anybody's feedback. If you find it interesting, if you need features building into it, let me know. So we switched over here to my terminal, and I've got a browser open with SCT, which is what I've called my little toolkit kind of thing. I've written it in Rust, which is a very fast compiled language. This website just sort of describes what it does, but essentially I know that SNOMED is published as these snapshots called RF2, I think release format 2, and they are completely incomprehensible to humans. Now that's kind of fine. I know this is meant to be a computable medical language, but if you're trying to learn this stuff, it is insanely infuriating to not be able to find any way in when you've got, you think, oh great, I'll download SNOMED and I'll have a look. There's not even a README that's sort of in those files, that just a couple of bytes just to tell me what to do, just to get me started. So you have to work it all out for yourself. Anyway, I've tried to make that a little bit easier. So this platform essentially takes the RF2 release and turns it into new line delimited JSON, which is a much more modern data format that works pretty well in in sort of modern tools, and anything that you can use to edit JSON or process JSON, you can use with this. So it's kind of a bit more flexible, and you don't need any like special tools. You don't need to get permission from the high priesthood of SNOMED to do it. You can just get a release and do this. So let's do it. You have to install my program first. The best way to get that is to just git clone the repository. I'll put links in the show notes so that you'll be able to find it. And then you have to cargo install, which is using the Rust's compilation toolchain to build it and install it for you. And if you want to try the terminal user interface and graphical user interface, which are kind of experimental at the moment, if it's working, then you should be able to type this, get a response. And I've tried to document things as I've gone along. This command will get your RF2 file, whether it's in a zip or whether you've already extracted it from the zip, it doesn't mind. It will output it as SNOMED.NDJSON. And it takes about 30 seconds to do that, which I'm quite pleased with actually, because when I tried doing similar sorts of things with the orthodox tooling produced by iHitsDo, SNOMED International, whoever they are, that took an awful lot longer, notwithstanding the fact that I had to download a big Docker container, do a lot of messing around with the Java heap to make it actually not run out of memory when I was trying to install the entire monolith edition. I think the clinical edition did work, and to be fair, I was using Snowstorm Lite, which is designed for sort of lighter duty stuff, so maybe with full Snowstorm it would have been easier. But anyway, that's now created my NDJSON file. We can use tools like JQ, which is designed to just do querying in JSON. So if I just put that command in there, we're going to query by SNOMED ID, and you just put that in there, and it's found my myocardial infarction. Now you can actually see this is like a much easier to reason about. So you can see it's got parents, and you can see it's got a CTV equivalent. Now you can start to learn about SNOMED in a proper sort of interactive way. There are other tools you can use that are just kind of, normal Linuxy tools like grep. You can grep to see how many procedures there are, and just use WC, which is word count, to give you a number of them. So that's kind of immediately made it a bit more handy. We can do similar things like let's look up via CTV code. So doing the opposite of looking via SNOMED code, and obviously gets us the same thing. You can take this NDJSON file and you can use it in your programs. So if you've processed it into this, then it's a good way of incorporating it into a program. And I can guarantee you it will be faster doing that on disk locally than it will be to call an external terminology server, which of course includes a sort of TLS handshake and the API round trip. So whatever the query takes, you have to add to that the entire network request, which is just huge compared to stuff that you can do on disk. Next up, we want to go and make something like, let's turn the NDJSON into a little SQLite database, which gives us some optimizations and indexing and makes things faster, but is still right here on the computer and is a single file. So this is processing all of that NDJSON into a SQLite, and as you'll see, it's not going to take very long. Worth mentioning that you can open that NDJSON file, even though it's 1.1 gigabytes for the monolith edition, you can open that in a text editor. Okay, so I mean, not the world's easiest user interface, but what I'm showing you here is the whole of the SNOMED-CT monolith UK edition loaded into VS Code all at once. And as you can see, I mean, it's 1.1 gigabytes of JSON, but because it's new line delimited JSON, it just seems to be able to cope with it, whereas an enormous JSON string would have crashed VS Code long before it got loaded. But I can load the whole thing in and play with it. So I mean, if I want to do, I can do a search and say, I'm just going to look for, not bad. I mean, that's a in typing speed search. It's found me all the myocardial infarction, everything that's got myocardial infarction in it. All of this just happening on my laptop. And this is the furthest I've ever been able to get with SNOMED. I mean, I've learned a lot about SNOMED over 15 plus years of becoming and being a clinical informatician, but I've never actually had any decent tooling that I could use just like on my computer, because it's all so shit. It's either expensive, or it's difficult to set up, or it requires knowledge that I don't have, or you've got to work at NHS Digital to get hold of it, or you've got to work at Primus, or you've got to work at SNOMED International. So like, part of my aim with this was just, can I do something for me? But now I'm sort of thinking, you know, this is out there so that everybody can use it and learn from it. Right, back to where we were. Before I was showing you the VS Code thing, I converted the SNOMED.NDJSON into a SQLite database. And once you've done that, well, the world's your oyster, because your LLM is absolutely brilliant at working out SQL queries. So if you tell it what you want to query, it will, even if you just give it the database file, it will know how to query the database file to find out what the tables and the column headers and, you know, how the structure of that database is. So even if you didn't know anything about this, it would be able to give you some good queries. Let's give you a query. Just drop that in here. So that's kind of, I mean, it's instant. When I've done this, it's so fast, it's sort of not registering at taking any time at all. But I think when I did benchmark it, it took about between 1 and 4 milliseconds to do most of the queries. And these are only simple queries, but you know, we can do something that's a bit more exciting. Recursive subsumption via is a table. That's also instant. You can write any query you want now, and you don't need special tools, you don't need special knowledge. If you can write SQL or have a little LLM friend who can, then you can immediately do that. I've done a SCT command, which is called lexical, which does lexical searches, and just means that if you just want to search a word, you just type SCT lexical. So what I did 3 searches there. So SCT lexical, you tell it which database you want to use, and heart attack limit 10. So it's going to give you 10 that have exactly the lexical match of heart attack. And it's also got some synonyms. And then clinical findings that include diabetes, and then AMOX, and then anything after that. So like a wildcard search. This is all very, very much like a pre-alpha thing. So if there are bugs, please tell me about them. I will fix them. But at the moment, it's quite a promising way to be able to play around with SNOMED and really learn about what's in there, and maybe even make it easier to use so that we can get better tools out the other end. You know, in the end, the purpose of SNOMED is not for me to play around with it in the command line. It's so that we can use it clinically. And part of the reason I think it's not very easy to use clinically is because the user interfaces we have are pretty rubbish. And they're from a previous generation of computing. You know, we don't have the really cool user interfaces. That's what we need. I included cross-map tables. So if you want to give me the CTV3 codes that go with that SNOMED code, and the first one was actually the comment that I copied into the thing. That's the actual response there. And then go backwards. So find where the code is a CTV3 code of that, give me whatever that is. So that's a little bit cumbersome. Maybe I'll wrap that in something a little bit neater. Then we get into some fun stuff. You can export the NDJSON into something called a Parquet file, which is like another form of database on disk. I gather it's used quite a lot in the sort of big data analytics and archival world. So let's take our NDJSON and turn it into Parquet files, or a Parquet file. So that's done. And then we can, using DuckDB, which is a database that can understand Parquet files. So essentially it's again, rather than having a database as a server, which has an overhead of like running it and updating it and loading in the data and stuff, these are just files. And I've never really understood why files aren't used more for all of our data needs, because they can do everything that databases can do, and to some extent they're a lot easier to do things like archival with. They don't have some of the understandability problems that you get with a database. I think the bar for getting involved is just a lot lower. So you get nice little tables with DuckDB, but this is just grouping all of SNOMED by hierarchy, and as you can see, that was virtually instant. Got slightly into all kinds of other ways of representing this stuff. So you can represent SNOMED-CT and output the whole lot as Markdown. I'll do that just to show you it doesn't take very long. This is going to create 831,000 Markdown files in the repository that I'm in at the moment. And last time I did it, it took about 15 seconds. Just be a bit wary with this one, because you are going to create a lot of files, and if you open them in a file browser, it will slow down significantly and it might even crash. But nevertheless, it's kind of handy to have these things. And if you have a look at any of those files, well, I might as well show you. It looks like that. And so it's Markdown, so it's a nice kind of structured text form that you can read. And again, for understanding what is going on here, it's got the entire hierarchy down from a concept to it's a clinical finding, it's a finding in the trunk, it's in the upper trunk, and you work your way down and you go, okay, so that's how it works, right? Much easier than trying to sort of puzzle your way through by doing ad hoc queries on, I don't know, the NHS term browser. There you go, that's the hierarchy. I mean, none of this is hard, right? It's just not been done. Now we're getting into slightly exciting territory. The way that LLMs work internally is that they make embeddings in many thousands or millions of dimensions that encodes like the meaning of a set of words or a concept. And that's kind of the whole point of what SNOMED-CT is. You could actually replace the term with a vector embedding. Now this does take a while. I did it just now, it took about an hour. And I'm not sure that I've ironed out all the bugs in this, so I'm not actually going to show this, but by all means, have a play with it. It uses an open source embedding tool, which you run on your local laptop, and that takes every single code and its rubric and embeds it so that you can compare them for similarity. And the idea is that eventually, instead of just doing lexical matches, you could actually do semantic matches. And it does work, the code works for that, but at the moment, I'm not convinced that the results are right. So this is doing a semantic search. I've searched for blocked coronary artery, which is of course unlikely to be actually word for word in SNOMED. So what it's doing is looking for things it thinks are similar to that. This is the fun of dicking about with computers, like, mess about and find out. Then I thought for a final thing, I would make an MCP server, which are all the rage these days, but essentially they're a standard set of tools that you can give to an LLM so that it knows how to interact with something outside the LLM. And in this case, I want it to be able to interact with SNOMED-CT. This command is something that Claude Code or Claude Desktop or Open Code or any of those kind of harnesses, they can run the command for you. So you don't have to sort of start it and then go into Claude Code. This will run that command. So as long as SCT is installed on your system and it's got access to a database, you have to tell it which database you want it to use, and it will just work. So go into Claude, and then we could say so it knows it's got access to SNOMED-CT via the MCP, so it is going to go and have a look. I know that SNOMED inherited a huge number of quite esoteric codes from CTV3 and possibly from Read 2, So, I mean, some of these are obviously quite reasonable. It's the ones where an aircraft and a spacecraft are involved, which I think are quite, these ones where it's like, whoa, I mean, the amount of imagination you have to be employing to get to there, I think it can only involve psychedelia, in my opinion. But anyway, good on them. But so I've been able to give a kind of very free text request into my LLM, and it's been able to search very rapidly within SNOMED-CT. Totally, you could ask Claude on the web or ChatGPT, and it could probably do some Googling, and it might find a way of accessing a website where it can get into SNOMED-CT, but it will not be able to do it as fast as this. By several orders of magnitude, because even if they're not blocking bot requests, then just the fact that it's going to have to try and use the kind of like web interface to do a query, and it's really not set up like that. I mean, part of my rant at the beginning was that the tooling is actually kind of difficult to discover, very poorly documented, not at all accessible for the non-expert. It sort of all assumes that you already have been doing this for years, and that you were shown by one of the other SNOMED priesthood. So this just gets you started. You can immediately be making queries. Now, I have no doubt that you could ask Claude at this stage to create you a ref set. Whether that would be a clinically safe ref set, I very much doubt. But we, in a period of 8 days of work, we've got to a stage where we've got a really useful tool here. I know that there are MCP servers that sit in front of other terminology servers, but again, they suffer from the network request issue, which is that all of those things take a lot longer because they're going across the network. And actually, when I've tried it locally, they even take longer if you're running them locally on your machine. So it's just a fast and cool little thing. So what's next? Interactive UIs. I will save them for another video. I want the graphical user interface to be actually nice, and I want it to be helpful. I want it to guide and teach, as Larry Reed would put it. And I want it to have a graphical representation of the entire of SNOMED-CT in it, so that you can kind of float around inside the blobs and see what the ISA relationships all do and sort of pull it around. I've got a bit of that working, but I don't think it's ready. You can compare releases. I haven't actually tested this feature, but I think it works. You can diff between 2 different releases to see what changed, although I think what you're going to get is just like a massive blur of stuff in the command line, and you probably then need to go through that to kind of work out what changed. And the other thing that I would like to do in the future is make it easier to curate lists of codes, because I think one of the most powerful things that we use SNOMED for is searching within lots of medical records for patients that have one of a list of these clinical codes, and then we can do something with them. So that's how GP payments work. That's how the COVID shielded patients list worked. We search to say, have they got any of these conditions? And it's how we want things like clinical decision support to work in the future, where if you've got this SNOMED and this SNOMED code in your record, then we should offer you this treatment or whatever it is. But managing those code lists is currently done just as badly as the rest of the industry does it. It'll be in a Word document, or it'll be in an Excel spreadsheet, and the person that owns that Excel spreadsheet will know in their mind what it can be used for and what it can't be used for. But we don't have any decent ways to like share, remix, and inherit and sort of federate these code lists. The nearest anyone's got to this is Open Code Lists by the team at Open Safely at the Bennett Institute. And they've done a very good job of collating some of that stuff and making it public. I still find, because it's all in a database, you can't just like get it on your computer and just edit it in a text editor. And I'd like to be able to bring the benefits of version control and determinism to these code lists. So the idea here is I'm going to sort of spec out what a good code list would look like, and some tools that help you manage, create new code lists, scaffold them out, add codes to them, validate them, all of that stuff. And then we almost need a runtime then that can just go and take a code list and say, if you've got any of these codes, then do this. And it starts to make things much more like real programming. Whereas I think for far too long, some of these, the world of terminologies hasn't been that close in to real programming. I'm sure I'm offending loads of people here who are doing this really well across the world. I have to say, this is my experience as a UK-based informatician trying to work within organisations in the UK. Not all of them have been that helpful, but I think there's a lot that we can do to make things better. That's a little bit of a tour. I'd be very interested to see what people think of SCT, and I'd love it for people to download it, play with it. If you find it useful, give it a star on GitHub. And share it in some way with other people who you think might find it useful. Let's start a revolution. We can make the tooling a lot better if we've got somewhere to start from. I'm very happy to collaborate with other people. I'm very happy to get feature requests. I'm even happier to get bug reports and pull requests that fix them. I'll probably put it on Open Health Hub so that people can talk about the project and what they think of it. I will do an update in a couple of weeks with any new features and improvements. And of course, in the meantime, if you want to have a play with SCT, it's on GitHub right now.